Alright, you guys, we're going to be continuing on to learn about some more properties of equality, which these are properties that happen while you're solving as well, but it could also be tools that help you just to rearrange your problem or just to kind of make the problem flow better. So, our next properties of equality that we're going to talk about, the next one is called the reflexive property. Now, what word does the word reflexive kind of sound like? Holy hot dog, you guys. It does sound like the word reflection. So I always think about a reflection when I think about the reflexive property. So the reflexive property is when something is equal to itself or something is congruent to itself. Because if you have something, it should equal itself, right? Something, if you have like an angle, like angle B should be equal to angle B, or angle B should be congruent to angle B. Okay, so the reflexive property, what I imagine, is that there's a little mirror hanging out on my equal sign or my congruency symbol, and basically the value on one side will see its reflection through the mirror. So like A will see itself in the mirror as A, or A will see itself in the congruent mirror as A. So whenever something equals itself, that is called the reflexive property. All right, now, the next property is called the symmetric property. What does the word symmetric kind of sound like? Man, you guys are on it today. The word symmetric does kind of sound like the word symmetry. And let's see here. Symmetry means that something is the same on both sides or mirrors itself. Okay, so like when we talked about reflections, they had lines of symmetry. So I always envision like there's a line kind of sitting in between the two statements, and you could reflect one statement over the other. So the symmetric property is basically when you can switch around an equal sign. So like if A equals B, that is the same thing as B equaling A. So A and B just simply switch sides of the equal sign. So I envision my line of symmetry. If I were to reflect A equals B over this line, it would be B equals A. Or if you envision this was a piece of paper, if I were to fold my paper along this line, the B and the A would be lining up on top of each other. So this has symmetry, but to its most simplest explanation, okay, all this is when you just reverse an equation around. So if 4 plus y, or 4 plus x equals y, then I could reverse this. Y equals 4 plus x. And again, if it helps to see that line of symmetry, I could flip this statement, bam, over the other statement. And it would line up or mirror itself. Pretty cool, right? I know. Let's keep going, though. So the next property is called the substitution property. Okay, I know that a lot of teachers like to say that you plug it in. Ugh, I hate saying that. So, plug it in is not proper math terminology. Okay, the proper rule or property that we need to talk about is the substitution property. So, technically, every time you say the word plug it in, you are saying the wrong thing. You really should be saying the word substitution. So we're going to practice really hard saying the word substitution. Just go ahead and say it to yourself. Get that plug it in out of your system right now, because substitution is the proper terminology for that phrase. But anyway, so to substitute something is when you replace a value with what it equals, just like when a substitute replaces me as a teacher. So if A equals B, then A can replace B, or B can replace A in any expression. So if I have y equals 2x plus 4, and I know that x is 3, I can substitute in 3 for my x and replace x with a 3. So that x will transform into a 3. Okay, so that is the substitution property. Alright, the next property is very similar to the substitution property, but it is called the transitive property. So it kind of has a substitution quality to it. So the transitive property has a nice rhythm to it, a nice flow. So this is how it goes. if A equals B and B equals C, then A equals C. So if A equals B, B equals C, then A equals C. So it kind of has this flow. If you have two statements that equal the same thing, then they have to equal each other. So it's kind of like substitution in a way. Usually when we use the transitive property, I also accept substitution because you're kind of like if A equals B and B equals C, then you can replace B with a C. Alright, so you're kind of substituting in a way. So another thing to look out for when you guys are using the transitive property, it will always have this repetition around the word and. So if you see B and B, if A equals B and B equals C, then A equals C. So you're looking for that repetition. Okay, just like down here, if angle 1 is congruent to angle 4 and angle 4, see how there's that angle 4 and angle 4? That part will always repeat. So that's another way to kind of see that it's the transitive property. So if angle 1 is congruent to angle 4 and angle 4 is congruent to 6, well, that must mean that 1 and 6 have to be congruent. So that is the transitive property. Alrighty, so examples 6 through 9, we are identifying which additional properties of equality we will be using. So we will identify which property of equality is being shown in each example. So example 6 says if the measure of angle A equals 2x plus 3 and x equals 3, then the measure of A equals 2 times 3 plus 3. So what is going on here? Okay, I had a statement. I knew the value of x, and x was replaced with what it equaled to 3. So what is it called when we replace a value with what it equals? It is called the substitution property. That x is getting substituted with a 3. Pretty cool, right? Okay, example 7. We have segment PF is congruent to segment PF. So again, there's this little mirror when something sees its reflection in the mirror. What is that called when something is congruent or equal to itself? You guys are super smart. It is the reflexive property. Neato, you guys, neato. Alrighty, example 8. If TR equals RS and RS equals PB, then TR equals PB. So it has that flow. If TR equals RS and RS equals PB, then TR equals PB. And if you see here, it has that RS and RS, that repetition. So what is the property that has that nice flow like that? It would be the transitive property. You guys are on a roll. I don't know why I teach you guys anything. You always know the answer to all my questions. And the last one, example 9, which you probably already know. But anyways, if x equals 4, then 4 equals x. So when we spin around an equal sign or flip it around, reverse it, or if you see here, if I were to draw a line right here, it would mirror the other side or have symmetry with the other side. So which property tells us that we're allowed to reverse an equal sign or has symmetry when I reflect this statement over to this statement? You guys are too cool for school. That would be the symmetric property. So those are our 4 additional properties of equality that will help us either while we're solving or it'll kind of help us to organize our work a little bit better. So yeah, nice job, you guys. Way to go.